everybody, and welcome to the Wednesday night modeling stream. How are you? I'm Bryan Bentley. I'm your streamer. I'm the department head here at cgspectrum.com. For all your modeling needs, go to cgspectrum.com/3D-modeling. Oh, it's been a good day. It's been a really good day. Getting my vaccine pretty soon on the 28th. Gonna get my jab in about 4 days. Hashtag invincible. It'll be really good. So, what am I going to do today? I really don't have a plan for today, to be completely honest. But I have had a lot of students asking me about foliage, like how to do foliage. There's a bunch of different ways to do foliage. You can do foliage in Maya. You can do foliage in, pretty much anything. I'm going to do it in Houdini because I love Houdini. I'm a big Houdini convert, especially for procedural modeling. Basically, anytime I have to make a lot of really simple stuff, leaves, feathers, scales, twigs on a surface, I usually go to Houdini for this. And you can mix and match. Like you can hope maybe if I have time, or maybe next week, I'll show you how to take your stuff that you build in Houdini, and if you're really comfortable in Maya, maybe you can put it back in Maya. Maybe you can use Maya Mash to put stuff together. Like if you're not comfortable in rendering in Houdini and you want to render in Maya, you could do that. So data is data is data is data. Let's see, where do I want to start with this? All right, so I think I'm going to start with, actually, you know what? Before we do any of that, I got to talk about something that we need to understand how to work in Houdini, and just really how to actually work in CG in general. And this becomes very, very important when we're trying to place and rotate and get our objects to orient properly in 3D space when we're putting them on these points, because points inherently have no rotation. So we have to build their rotations. So, oh God, oh, it's coming. A math lesson is coming. Yes, math. So, we all know that we have, let's see, let's do my colors here. My colors. There we go. We have X, Y, and Z. So, let's clear that. We have X. We have Y. And we have Z. All right, so in case you don't know, this is what is called a coordinate frame or a transformation matrix. Yes, I'm talking about math, people. Talking about math. It's really important. And when I say math is important, I don't mean knowing how to crunch the numbers yourself. I mean knowing what those numbers mean. Now, I have these three vectors, right? These vectors are a unit length of 1. So this guy would be a unit length of 1. So this would be 1, 0, 0. So X, Y, Z. So I'll go ahead and put that in there. Let's type this out. I'm going to do 1, 0, 0. X, Y, Z. This guy here would be 0, 0, 1. Right? And this guy here would be 0, 1, 1, 0. Hey, Murat, what's going on? Just doing a little math recap. Okay, so the idea, so this we can rotate this. This is a rotation matrix, right? So if I were to draw this out in matrix form, it would look like X would come first, 1, 0, 0. Y would come second, 0, 1, 0, and Z would come last, 0, 0, 1. So we've probably seen this before in math class or in other math tutorials, and then you see this and you're like, ooh, and you just tune out, right? So these numbers the actual numbers don't really matter overall, right? It's the visual representation. We need to know about the visual representation of these. So if I have any of these two sticks, I can generate the third one with, you guessed it, the cross product. Okay, so this is what's going to determine my rotation in Houdini, right? I'm always trying to build some sort of frame like this. I'm always trying to figure out, all right, how do I get two of these little sticks so I can build the third. And there's another technique called the double cross product, which I may or may not get to. Okay, the double cross product. So we have one stick that we absolutely want. We get pretty close with the second stick. We take the cross product of those two, and then we take the cross product of the result of that to get our third stick, right? So you can do this with any of these. They're not special in any way, shape, or form. Like I could swap my X and my Z, or my Y and my X, or my X and my Z. It doesn't really matter. It just depends on how you want that thing to rotate in space. Okay, so this is how we generally think of rotation. So this is a 3x3, so 3x3 matrix. So 3x, 3x3 matrix. Okay, this can also be called a rotation matrix. Okay, so we have a 3x3 matrix or a rotation matrix because we think of our rotations as this thing turns around, as this thing turns in space. And we can even see this if we look down here at our little gimbal thing here. As we tumble around in space, that thing will move around and rotate as we need, right? Pretty easy to understand. Like, I don't really need to know how to do any of the like math to do this, because that's what the computer's for, right? It's nice if you know how to do that. Like, if you're like a super genius like that, that's cool, but I am not, right? So I let the computer do the heavy lifting for me, and I do the, kind of, so you feed the computer logic, it goes beep, boop, beep, bop, beep, and spits you back out numbers. I became a much better computer graphics artist once I wrapped my head around this, and once somebody explained this to me. So James Tooley, if you're out there, thank you so much. James Tooley was my supervisor when I worked at ILM. Dude is an absolutely phenomenal teacher and even better mathematician. Taught me pretty much almost all the stuff that I knew starting out with mathematics and in CG. So thanks, James. Big up to you. Anyway, okay, so where was I? Right, 3x3 matrix. So this is how we represent internally. This is how computer graphics represent rotation. So how else can we represent rotation? Okay, we can represent this as Euler or Euler angles. Now that's it's spelled Euler, I think. Euler rotation. Let me look that up because I'm the worst speller on the planet, as some of you may know. Let me look that up. One second. Euler. Euler. Sorry. Euler. Euler rotations. Okay. So this is how we typically think of rotations in CG. So you can call it Euler, you can call it Euler, depending on who you talk to. We'll say right. I'm going to use the word Euler from now. So how do we usually rotate stuff in CG? We have like those three rings, right? So we have our Y rotation, we have our X rotation, right? And then we have our Z rotation, right? And we rotate this little ring, and we rotate that little ring, and we rotate that little ring. This is very artistically friendly, right? It's artistically friendly because I was like, I want to rotate this much, that much, and that much. Under the hood, what this is doing, like these little rings, is it's rotating these vectors under the hood. So this kind of gimbal ring that we call it is directly generating that information, okay? So this is Euler rotations. Now, this is great for artists. It's terrible for computers, right? It's really hard to have these three just numbers build this thing. It's very, very hard to program against Euler rotations. So there is another type of rotation, and this is like the best kept secret in computer graphics, right? It's called a quaternion. Okay, let me look up how to spell that right. So that's quaternion. And that is spelled, so let's clear this out. So that's Euler rotations in 3x3 matrices. So just like you can describe weight in a bunch of different ways, you can describe weight as pounds, as kilograms, as foot pounds, as newtons, as all this stuff. You can describe light in a bunch of different ways. You can describe lights in watts or candelas or lumens. You can describe rotation in a bunch of different ways. So we can describe it as a 3x3 matrix. We can describe it as 3 Euler values, x rotation, y rotation, z rotation. We could also describe it as a quaternion or quaternion. I can never pronounce it right. Quaternions. Quaternion rotation. Okay, so this is strange. So quaternion is a vector. So it has an x component, a y component, a z component, and a w component. So what does this mean? This is very, very simple, and it's very easy to visualize. So my xyz position is just a vector in space. So xyz. That's my xyz. Okay, and what the W is a rotation. Whoa, too big. Is a rotation around that axis. Okay, so this is much easier to program against. I just tell something which way I want to point, and I spin it around that axis like a wheel. Okay, so. And the cool thing is I can convert a quaternion into a 3x3 matrix. I can convert a 3x3 matrix into Euler rotations and vice versa, right? So I have this very robust way of describing rotation in space, and that's how you describe like how leaves sit on a vine, how feathers sit on a surface. I'm working on a way where you can where I can use Houdini's grooming tools to make game card hair, and it's all based on this information. Okay, so 3x3 matrix, rotation matrix, quaternion rotation, and cross product. Right, 4 mathematic principles, and you can do a lot of damage with this. So let's see this in action, shall we? We shall. Okay, so the first thing I'm going to do is let's make some like ground scatter, right? Like I want like twigs and leaves and stuff on the ground. Actually, you know what? Let's do something a little bit more exciting than that. Yeah, let's do twigs and leaves on the ground. So I'm gonna clear this. All right, so the first thing I want to do is I do have some assets that I usually use for this type of demo. So I went on textures.com and I have some. So I have this kind of atlas of leaves here, and I have this palm frond, and I have kind of like these palm tree trunk maps that I can use, and I have like opacity and all. So the first thing I want to do is I want to make my leaf. So I'm actually going to save. So I'm going to say file, save scene as, and I'm going to put it in that folder just so I have easy access to all this stuff. So I'm going to say Control C, Control V, and we'll call this foliage. So I can access all those by, dot hip. All right. So the first thing I need some leaves. So what I'm going to do is, once again, I always start with a geometry node, and we'll call this leaf. Leaf. and twig. Let's let's pop inside of here. And the first thing we need is a leaf. So a really, really cool node inside of Houdini is called the trace node. So what the trace node does is it takes an image and it will try to trace the black and white values of that image. Super, super handy. But the problem is it makes really, really heavy geometry. So we need to deal with that. So let's see. So I'm gonna grab a file. So I'm gonna go to my hip, and I'm gonna go get those leaf textures. So accept. So just like that, there are all my leaves, but they're way, way, way too heavy. Okay. So I need to edit these a bit. So first thing I'm going to do is I can do a remesh. See what we can get out of this. So let's do target size. Let's bring this down. There we go. So that's going to take care of our middle bits, but our outside bits are still really, really, really heavy. So I'm going to do a resample on the outside. And let's look at our edge length. Let's see. And these leaves are also quite large. Like this guy is almost a meter. So I always want to make sure stuff is in real world size. So I got my little handy calipers here, and I'm going to say a leaf is about, let's say, I'm going to guess this is about, yeah, it's about 90 millimeters. So I can remember, I'm going to write that down over here. Leaf equals 90 millimeters. So I'll scale each one of these down eventually to be that size. Okay, so what was I going to do? Oh yeah, I need to clear out, I need to edit these edge points because I have tons of edge points and I don't need that many. So I'm going to do a resample. Let's see what that gives me. Yeah, there we go. So that's a little bit too light. So I'm just going to kind of start to pull this down until I get almost the shape of my leaf, but not so detailed. Because I'm going to have a lot of these, so I don't need it to be super bonkers detailed. Yeah, there we go. And the great thing about this node as well is that it does my UVs for me. At least I think it should. Let's see. Borders. Oh, there's a resample shape in there. That's pretty cool. Let's go back to here. That's new. Oh, that's great. I can just resample this here. I don't even need the second resample. Learn new stuff every day. There we go. So let's keep going up. And yeah, there we go. Great. Awesome. So fantastic. So the great thing about this as well is it makes my UVs for me. So if I look in here, I should make my UVs. So what I can do is a UV project. Okay. So if I look, this should do a UV project just like that. Bam. Okay, so that gives me my UVs, and I can do, to get my image, I can do a UV quick shade. I think I just blew Marat's mind. I can do a UV, let's do UV quick shade. Okay. And then I can say, I can go and grab the color of that guy. So that's, let's see, that's my translucency, my roughness. Where's my albedo? Translucency. Where's albedo? Okay, there we go. So my albedo's a little dark, but that's fine. Cool, great. And I want all this stuff to face forward in Z. So I'm gonna reverse this. Boom. Boom. Right, so now I have all my leaves, but they are completely flat. So I'll just run a mountain. I can run a, actually I don't want to use a mountain because it's a really old node. I'm going to use an attribute noise. So boom, boom. And so by default that does CD. I'm going to do P. So that's going to make them really big and like kind of too distorted. So my range values, I want them to be 0 centered. And I'm going to take my amplitude way, way down. And I'm going to take my frequency up just a bit. So I'm just trying to give them some wobble, just so they're not completely flat. So let's bring that element size down. Awesome. Cool. So now the next thing I want to do is, now that I have this atlas, right, I want to get all these guys down to the center, right? Because they're still kind of out in space, and if I try to like pluck these and put these onto something, I'm gonna get like these stamps of leaves everywhere. So to do that, I need to go through each connected leaf. So I want to do something to this connected leaf, something to that 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 connected leaf. So that is called a for loop, or a for each loop. It's a programming term, and it's also a set of Houdini nodes. Oh man, guys, my throat is really, really dry today for some reason. Okay, so let's do a for each, where is it? For each connected piece. So this lays down 3 nodes for me. So one, it lays out this connectivity node. And this node confused the bejesus out of me when I first started using Houdini. I was like, what does it do? Because you plug it in, and you look at it, and like, it didn't do anything. Except, what I've done, let's put this to point. So it gives me this class attribute. So this is why I tend to work a lot with my geometry spreadsheet. Because a lot of times when you're having problems, there's something going on with your attributes. Because that's what Houdini does. It makes attributes and then it acts on those attributes. It makes attributes and acts on those attributes, right? Attribute, action, attribute, action. That's how Houdini works, at least at this level. Okay, so what this has done is, let's just show this. I'm gonna bypass this quick shape real quick. So I have this class. So I have 0 to 7. So I have 8. So I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 leaves, and I have 8 classes. So what it's done is it's found everything that's connected and given everything that's connected a class. And I can actually visualize this. If I drop down a color here. And I want to say random from attribute. And that color, it's got class. Not ramp, random. And so if we look at this, right, each one has its own class because each class is getting its own random color. Okay, so it's basically taking that and it's looping through. It says piece attribute. My piece attribute is class, and it's looping through each one. So what I'm actually going to do is to test. So the for loop can be. Actually, no, I can do that. I can do it in here. So what I want to do is, if I come down and I view this, for loop, let's see. What have I done? Linked stops isn't generating any pieces. Point. I need to change this to points. There we go. Actually, no, I need to leave this as primitives and this as primitives. Okay, there we go. So it's looping over each primitive, and the primitive is not what we think of as a primitive in like Maya, like a sphere or a cube or a torus. A primitive is each face in this case. So if I turn on single pass, so that's one leaf, that's my next leaf, that's my next leaf, that's my next leaf. So I'm going to get one that's pretty far away. So I want to take this guy and I'll shove it down to the origin. Okay, so, and I'm going to resize it as well. So there's this amazing node called Axis Align. I've been abusing this node since I found out about it. Axis Align. It's in the labs tools. So I'm going to plug that in here. Bam. So now that guy goes all the way down. So I want to justify my Y. I want this right in the center. So I'm going to say center. Bang. The other thing I'm going to do scale to fit. So this is 1 meter. This is a 1 meter size. Let's turn this back on. This is a 1 meter sized leaf. So right now it's like this big, right? So I always want to make stuff in real world scale. So what I want to do is, let's say I said 90 millimeters. So that is 0.09 meters. 0.09. 0.09 and 0.09. Cool. So if I turn off single pass, all my leaves are stacked up next to one another. I still have this class attribute here, which I can do, and this shop path is coming from the UV quick shade. So the shop path is shading operator. So that's basically telling what shader is attached to what face. Cool. Okay, so I have my class 0 to 1, and I have my my leaves. Okay, so now what I can do. So this is my leaf. So I'm gonna call this out leaf bundle. Call it null. Okay, so they're my leaves, and cool. So now, so I said I want to do leaves and twigs as well. So for my twigs, I'm going to start with, I actually want my twigs to be about the same size as my leaves. Probably a little, maybe something like this. So for my twig, what I'm going to do is I'm going to start with just a line. So I could go on like Megascans or something and download twigs, or I could download an atlas of twigs, but I can make stuff myself as well. It's always good to be able to make stuff yourself. So I'm gonna make a line, and let's see. I want this guy to be about the same size as my leaves. So let's say 0.09. So it's about the same length as my leaves. Let's turn those off. So lowly line, pretty boring, but we can, so let's do maybe 5 points. And and I'm gonna add some noise to this as well. So we're gonna do, I'll just steal this attribute noise. So there's going to be my twig, and I only have 1 twig. Or actually, I can make... yeah, I can follow this same logic and make a bunch of twigs. So this is what I'm going to do. I'm going to take and make a bunch of twigs here. So I'm going to use a copy and transform. And so we'll make... So we had 8... we had 8 leaves, so I'll make another, we'll say 8 twigs, and I'll just move these over just a bit. And so now when I plug them into this attribute noise, I'm going to get pretty much the same idea. So so each one of these twigs is pretty unique, and I can push this a little bit further. So let's take our amplitude up just a bit. Size down. Cool. So I can do pretty much the same thing as I did before. So there's my attribute noise. So I'm going to take all this and just hold down Alt, move it over, and plug this in here, and I should get all my twigs at the center there. So maybe I can use a little bit more. Let's do maybe 10 points. There's going to be a lot of these things, so I don't want it to be too heavy. And for now, what I'll do is I'll just do a polywire. And once again, let's bring down this wire radius. So once again, I want to pull out my calipers. About how thick should this be? I think a twig is about maybe 15 millimeters, so that's 0.015. Might be 0.015. Yeah, that looks a little bit better. Awesome, cool. So these are my out twig. And I can give these some color as well. I'll just throw like actually I can randomize their color as well. So if I want to do that, let's see, how would I do that? Ah, okay. Let's do, let's see. So I have my connectivity here. So that's my class, 0, 1, 2, 3, 4, 5, 6. So what I can do is I can use that as a random 0 to 1, and I can have a spectrum of a controlled spectrum of colors. So what I'll do is here, I'm going to promote this attribute from primitives to points. So that's going to be an attribute promote. And so we'll plug this in, and I want to promote from primitive to point, and that is going to be class. So now we're here. I have my class 0, 1, 2, 3, 4, 5. Now, the other thing I can do is let's do, I'll do an attribute expression. And I'm like, I haven't practiced this. I'm just kind of going with the flow, trying to figure this out as I go along. So I need a value to plug into that. I need a value to plug into the color node. So I'm gonna I'm just gonna make a custom, and I'm gonna say rand. I'm just gonna call this ID. Okay, and my ID is just gonna be a single float. Okay, and so my ID is going to be random. Is it rand or random? I always forget. Rand. Let's see. Random. There we go. Random. But I don't want element num. I want class. Okay, so now I'm getting a random. So random returns, given a seed, it returns a value between 0 and 1. So now I can put a color on this. So if I look at this, I can use my color. Color, I can say ramp from attribute, and the attribute is ID. So now some of my strands are like this, are almost black, and some of my strands are almost white. So instead of black and white, I'll go with a dark brown to a light brown. in this poly wire should pick up. Yeah. So now I have sticks, and these are all, I always make my colors way too saturated. Colors in nature are very, very desaturated. Yeah, that feels a little bit better. And so I'm not putting a lot of detail in them because these are going to be like this, right? I just need to give it a hint that there's some variation in there. So I have something. So here I'm mixing proceduralism, photos, and Robert Alomar Vine, making plants, making it vine. I can make vines. I can show you how to make vines. Hopefully I'll get to that today. So right now we're just making ground scatter. Just like leaves and twigs scattered all over the ground. Okay. So I have these two lines. So I have my twigs, my twig bundle, and my leaf bundle. And so now what I'm actually going to do is I want to rewrite. Do I want to do that? No. Okay. So there's a new node that I kind of have been afraid of to use because I like the old ways. I fear change, but that's what this is. That's what this stream is for. It's to try new things. So the traditional way to do this is to scatter points over a surface and then build all your attributes. So there's a new node. It's actually a DSA. It's called scatter and align. So I need something to scatter on. So I'm just going to make a grid. And so this is 10 meters by 10 meters, which is pretty big, which is okay. And let's do 50 by 50. That should be enough. And I'm going to give this some noise as well. So I'm going to do tab attribute noise. And I'm going to do actually, I am going to use a mountain for this because the mountain uses normals. 10. Okay, that's way too noisy. Let's take our height down and our element size. I want this to be just kind of like gentle rolling. Yeah, there we go. So F1 cellular kind of looks like looks a little bit too much like water. That's too noisy. That's too noisy. Yeah, good old Perlin. Perlin is great for terrains. Let's see. Yes, righteous. Grass and twigs are actually more important. You can find tree geo, but grass and twigs is more difficult. Great. Okay, good. I'm glad that you're liking where this is going to go. Okay, so there's my ground. So I'm going to call this once again null out ground. No. Out ground. Okay, so there's my ground. Okay, so I'm going to scatter points using this new Fandangle node on the ground. It's called scatter and align. So this is actually a DSA. It's got a bunch of stuff in it. So it's a wrapper for a bunch of stuff that you can do. If I pop inside here, it's this giant mess. But, not mess, but it is at its core. There should be a scatter node in here somewhere. Let's see. Switch. Got a line, copy points. Ah, there it is. So at its core, it's this scatter here. So you could build this on your own, but they've kind of done it for you. So I'm gonna plug my scatter into here and show this. So now if we look at this guy, it's made all of this data here for me. It's made a tag, it's made a P scale, it's made an orient, right? So that orient is, look at 0, 1, 2, 3. 1, 2, 3, 4. That is that's my that quaternion, right? It's that quaternion. So I can view this. I'm gonna click my orient here, and I want to turn on my markers. Show this. Should be able to show my quaternions. Turn on my markers. Turn on my orient. And let's edit this. Let's see. That's why. I want to orient vs orient. Type, I want it to be a marker. And that marker, I want to be a axis. Awesome. So, once again, so this is why I went over that at the beginning. So this is my orient. My Y is facing up, my Z is facing this way, my X is facing that way. So I can visualize how these things are going to be rotated when I copy them. So just for now, I'm just going to do a cube. Actually, no, I'm going to do a rubber toy, because that has a definite upright and left. So I'm going to do a copy to points. So stuff to copy to. So there's my army of rubber toys now. Okay, so now what I want to do. Let's see. So I have my min radius, my max radius. So right now they're all at 1. Let's see. My minimum radius, I said I wanted to be, let's see, 0.009. And my max radius, what's going on? There we go. So I should save. This is making a lot of rubber toys. All right, so I'm going to save this. And let's cut that. So before I do that, I am going to say pack an instance. So I get some speed back. There we go. All right. So my min radius on these guys is 0.09, and my max radius is 0.01. So I'm making a ton of these things because they're really, really small. So if I go back to here, right, I'm getting more and more because it's packing all that stuff into there. So let's go 0.09. There we go. And 0.1. So it's packing more and more and more and stuff in there. So I can also bring up my uniform scale. So it's basically what this is doing. It's doing a packing iteration for you, which is really nice, right? So all my Y's, this almost already looks like grass, right? You can already see how this can kind of come together. But if I look, all my X axes, my rotation, are kind of all pointing the same direction. So I can do my point count method by size, by density, by point spacing, by number of points. But for now, let's just do by size. That's fine. Let's see. What else? Let's see. Random cone angle. Now, if I start to bring this up, you're going to start to see my X rotations start to spin. So that's how I can get random rotations out of everything. So the thing is, though, here, as I'm seeing, let's see. So it's spinning in all 3 directions. I only want it to spin around that Y. So let's see what I can get. Let's see. Rotation around normal. So let's maybe min angle. Hard to see what this is doing. There we go. So now my X's are spinning around. So my min angle, let's just push all the way up to 360. So they can turn in any direction. So now, like, this is super scattered. Right, so if I go back to here, all these little guys, they're all pointed in different directions. So I'm getting a p-scale and an orient out of that. Everybody says that. I've said that. I remember so me getting into computer graphics is it's the universe kind of messing with me. I remember saying in 8th grade math, and if my 8th grade math teacher, I can't remember your name, but if you're watching this or out there, Bryan Bentley says he is sorry because I said out loud during this class, during linear algebra, I said out loud, I will never use this in real life. And I literally use these mathematic principles every single day. So pay attention in math class, please, please, please. It'll do you quite well. Okay, so that's my scatter align. Okay, so now, but right now I'm always getting the same object. Okay, so I'm going to continue testing with this rubber toy, and then we'll get back to our kind of more naturalistic stuff. So I'm going to make a couple of these rubber toys. So I'm going to make one that is blue, and then I'll make another one that, let's put a color on here, and that should just tint this guy. Let's do green. Yeah, it just tints him a little bit. So we'll make a green guy, and we'll make a... Actually, you know what? An easier way to do this. I'm just going to do a copy and transform. And let's make like 10 of these guys. But before I do this, I need to... So he's a bunch of different pieces, right? If I go to this guy, and I put a connectivity on, here, if I look at my class, he's like 10 different pieces. So he's probably like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, he's 10 pieces. So I need to weld him all together. So I'm just going to Boolean. And the Boolean is generally a big no-no, but in this case, so now he should just be, yeah, he's all one piece, all one class. Okay, so I'm going to plug that into my copy. And now, so I have 10 copies of this guy, so I should get ten classes. And I think this might be... Let's look here. Okay, so I'm getting, let's see, here, connectivity. Point class. Yeah, cool. So now I can take that class and I can color each one of these guys, just like I did before. And we'll do random from attribute. From attribute. So I have a bunch of different colors for my guy, so I can like disco ball him up. Let's make sure that is point and that's point. Okay, great. So I'm gonna zero this out. So I have my little rubber toy that has all my classes built in. So now how do I feed all, because if I feed all 10 of these in, I'm just gonna get 10 guys stacked on top of each other. So there's another new node that came out very recently called attribute from pieces. So I'm going to do attribute from pieces. Where is it? Attribute from pieces. Here we go. So this is basically treating, so this is a geometry library and point cloud. So my point cloud is my scatter line. And my geometry library, and I don't like the way they've built this because I have to cross wires. I hate crossing wires, but no worries. So and then here's my attribute library. So I'm going to take this guy and plug it into here. So what this thing is going to do is it's going to tag, and let's see, my piece attribute is not name, it should be class. So it's going to tag each one of these guys with a class, and I can tell it mode, I can tell it cycle, I can do it patches, I can do it noise. Okay, so now I'm going to plug in all these guys into my copy, and my points to copy is going to come from my attribute from pieces. And let's see here, I also have to say piece attribute here. It's not variant, it's also a class. So now I'm getting all these different colors of all my little rubber toys. Okay, so I can take the same logic here, and I can do that with my my leaf and my twig. Now, the other thing that we can do is the scatter align has constraint points, right? So if I have constraint points, if I make another one of these, it will try to leave those alone. So I can like start to stack these up. So let's see. What do I want to be? So I want I would say my twigs are heavier. So they're gonna fall first, and then my leaves will fall in between wherever those twigs went. So I'm gonna do my twigs first. So I'm gonna disconnect. Let's see. I'm gonna put a null here. And I'm gonna call this in lib. For in library. And I'm just going to replace, this will go into here, and I'm just going to replace these connections into here and into here. So I can easily, so it's like a little mini asset, so I can easily swap out what goes in here. So let's go, and let's go, we'll put another null here, and we'll do out toys, out toy bump. Okay, so let's just swap out my twigs and see what happens. I think my twigs are really, really small, though. In lib, let's see, class. My class might actually be on, is it on my points? It is on my points. 1 through 7, let's see. So this class here, this is class 0 through 7, and then here, let's turn off pack an instance. Let's see, maybe my twigs are too small. Ah, they are. They're really, really, really small. So super, super tiny. So maybe instead of 0.09, let's just do point. Actually, I might just need more of them. And let's see. That's going to be these guys. This is what I find really kind of frustrating about these, because it's doing so much stuff for you. I have to figure out what this axis align is doing. So let's do point count method. Let's just do density overall. Let's just turn this up. Let's make sure I get enough points here. Yeah, so there are all my little twigs, and I want them to lay down on the ground. So if I go back to my attribute from pieces, and I view that, right, they are... So I should align them with either the X or the Z. So right now they're pointing straight up and down. So that's pretty easy to fix. I'm just going to take my original guy here, and I'm going to, let's see, let's lay him down on the ground like that. So 1, 0. Yeah, so they're all my twigs. They're all laying on the ground. And then here, they should also be laying on the ground. Yeah, there we go. But they're still really, really small. So that is probably going to be in here. Let's do... Let's see, these are still super tiny though, I think. Yeah, they're still really small. Let's see how big these are. They are quite small. So let's bring this up, maybe. I just want to be able to see them overall. They're still really, really small. What's my P-scale look like here? Yeah, my P-scale is like 0.0 something. So actually what I'm going to do is, if that's the case, particles on top of particles, like every leaf there. Yeah, you can. If you have a computer that's strong enough to do that, you can. So what I'm going to do is I'm actually going to leave this guy at 1. Because the P-scale is going to multiply that by that. And I'm going to set this also to maybe 1. There we go. So there are my big old pieces. So right now it's 1 and 1. So maybe we'll do radius like 0.5. Getting out of my bundle here. Let's bring this down. Okay. And I want to view this grid. Oh, there we go. So let's view that. Should be viewing this, and let's see, let's look at my P-scale. Orient P-scale 1.96. Size. I'm getting a few, so I'm going to take my min radius and start to pull this down. I should get more and more of these twigs. So they're getting smaller as I pull that min radius down. So I don't want to do by size. I'm just going to do number of points. That's probably the easiest way to do this. Total points. Okay, so I'm actually going to handle my P-scale myself. Because... it's trying to do too much for me. It's editing my P-scale, and I don't like that. But now, here we go. So I'm just going to I'll handle my P-scale myself. That's fine. But what this is doing is we can see each little twig is a different color. Okay, so now I can, let's start to tune these up. Like they're looking more like logs than twigs right now. So I'm going to go back to this guy and pull them down. So I have to remember, this is like a 10 meter by 10 meter thing. So this feels pretty good. Like if I was standing here, right, I'm getting like these little twigs here. Oh, good to see you, Robert. Right. So yeah, so here we go. Number of points, we can start to push these up a fair bit. There we go. So now I have like this field of little French fry twig things. Okay, so there's my twigs. So that's done. So now I know that I don't want my P-scale in here. So my orient is fine. So these guys are all pretty much the same size now. So I need to vary their size overall. So I'm going to do that myself with a P-scale with an attribute, the attribute noise, or an attribute randomize, either one. Yeah, so this align, the scatter align works pretty well. I like it for the orient, but I feel like it's doing too much. It's doing too much. So if I turn that on, like I want to control my scale, not this thing. Let's do orientation, and then yeah, so number of points, 36,000. Awesome. Okay, now I'm going to handle my P-scale myself. So I'm going to do an attribute randomize. plug this in here. And by default, what it's going to do, what it's going to try to do, is going to try to color everything. I don't want to color everything. I want P-scale. So now some of my twigs are really small and some of them are really big. So now what I can do is I can take, and I'm just going to make this a little bit easier on myself, I'm just going to put a transform here so I can just globally scale up everything. So that's looking pretty good. So I got like it's nice twigs, like all these twigs, they're all different colors, and they're all different sizes. Perfect. Okay. So that's one piece. So the other thing I can do is I can take this whole system, and I'm gonna hold down Alt and just copy the entire thing, move it over here. Now, once again, I haven't really tried this before, but if I have, let's take, and I can take I'm going to take the same grid and plug it into these scatter, this scatter here, and I'm going to take this orient value and make it a little bit smaller because it's a little distracting. Right, so there's that scatter, and so here it says constrain point cloud. So I'm going to take this original point cloud here and plug it into that second one and see what it does. So I think I want less leaves overall. Actually, let me let's look at the documentation for this guy. All right. Let's see. So this is what it's for. What is my tag attribute? This node creates a string tag to be named on tag points. It lets you name points generated by the node to use later in the align nodes. Don't really need that. Let's see. Here we go. Scatter points around constrained points. It allows you to cluster new points around existing constrained points. See, scatter around the constant points with avoid constant points, but without. Yeah, this is what I want, right? So I have my twigs, and I want to scatter my leaves in between here. Okay. So how do I turn that on? Let's see. Point cloud that can be used to specify which areas of the surface geometry that should be scattered around. Cool. Point spacing. Mode. Here we go. Scatter points on geometry surface. Add attributes to existing points clouds. Here. Scatter points around constrained points. Ooh, there we go. So that's awesome. Okay, great. So I want to say scatter points around constrained points. So what this is doing is it's taking my twig points and then putting bits around them. So I don't think I need, let's see, by point spacing. Let's do by number of points. And let's bring this down. So I want less leaves than twigs. My twigs are kind of everywhere. Let's do even 1,000 points. So here are my twigs, and then here are my scattered points. And then, so what I can do now is I should be able to take my out leaf bundle, plug that into here, view that. So here are all my leaves. So I think I need to do the same thing. I need to turn my leaves so that they're sitting on the ground, because these guys here so I want to make these sit on the ground, so I'm going to take another transform. And let's rotate these down. So there are my leaves all scattered across the ground, and here are my twigs also scattered. So my leaves still feel a little small overall. So let's take their uniform scale up. And let's take our seed, change it so they're not directly on top of them. Sure, I can do that. How much time do I got? Yeah, I got an hour. Can I explain the cross product? Sure, I can. All right, let's merge these together, and then I will explain the cross product. All right, so now I have twigs and leaves. So my twigs, I think I want to be a little bit bigger. Still. So I could do this with, I could add rocks to this. I can do, whatever I need to do to this as well. So let's play around with this scatter radius. Let's do 50. Yeah, there we go. And then if I want to bring my ground back into this, hold down Alt, click, and I'm gonna bring that Alt, click, and then bring that into, and there's my ground. So I may have to lift some of this up a little bit. So I'm gonna put a transform here. And I'm going to do a merge. So let's cut this. I'm going to do a merge here. So I'm going to take and just lift these up just a bit. And maybe I'll give my ground a little bit of color as well. It's like a deep foresty green. So still way too saturated. All right. Cool. So yeah. So that's a foresty ground kind of look. So I could color the ground a little bit better, but that's how you can make these patches. Possibly. Okay, I could do that. Money Val 9 is asking if I can make this project file available. I could do that. Yeah, stay tuned, and maybe next week I'll show you where I'll share a like a Dropbox link or a Google Drive link that you can pull this down and look at it. Okay, so I don't need my rubber toy anymore. want to save this. So that's ground cover. So I got twigs, I got leaves, all as well. Okay, I'm trying to think of a good way to show the cross product of something. Okay, I got an idea. Got about an hour left. All right, what I'm gonna do is I'm gonna make some vines that will crawl around the surface, and then I'll use that. Actually, that'll be perfect. Okay, so I still have. Let's see. I'm gonna make sure out leaf bundle. Okay, cool. All right, so we're gonna use the same idea on a vine. Okay, because right now, like, our orientation is pretty simple because everything is on the ground and most of the stuff points upwards. So I'm gonna do a file. I'm gonna go get like this really cool model that I really like using for examples. It's a little heavy, but it should still work. Hip, demo head. And how big is this thing? Yeah, it's like 10 meters. It's quite large, which is fine. So we're gonna cover this thing in ivy. Okay, so the first thing I want to do is I want to make my lines. So I want to make them grow from a couple positions around this neck, and I want to make them grow up and into the head. So the first thing I need to do, and how heavy is this guy? Oh, he's not too heavy. The first thing I need to do is make some, create some start points. So I'm just going to select a few points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 points at the bottom here. So I'm going to say tab. I'm going to group those points. And I'm going to call this start. And I'm going to do the same thing. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 19, 20, 21, 22, 23, 24, 25. So we'll say 25. Same thing. Group. And we'll call this end. Okay. So I want to draw lines between my start points and my end points. So there's this really cool node called find shortest path. So my find shortest path is going to say my start points are going to be my start, and my end points are going to be my end, and it should give me how many primitives do I have? That many primitives. And I'm going to say from any start to each end. Why are you not giving me lines? Oh, because I'm going from start to start. I need to go from start to end. There we go. Sweet. So I have these lines kind of crawling over this dude. So, ooh, that's nice. From each start to each end. Let's do from each start to any end, any start to each end, each start to each end. So this might make me too many points. Let's look at my point numbers. Okay, they're not overlapping too much. Okay, so I have this mass of lines going over this guy, which is what I want. Looks really cool, right? So these are going to be my vines. So how I'm going to determine, how do I determine which way my, let's see, that's so cool, man. The expression works. How it seems a bit more complicated here. Oh, no, it's not super complicated. So how this is going to work is, so I have my surface. So this is going to be my surface. my surface has normals. And then, so my vine is going to crawl over that surface. Like this. Now, my vine has points on it. So my vine has a point there, 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 and a point there. So I can have a vector that points down the length of my vine. So I'll have a vector that goes, starting to run out of colors here. Let's do this bright blue. So I have a vector that goes like this, and a vector that goes like that, and a vector that goes like that, and that, and that, and that. Okay? So I have two vectors. So I have this vector that goes along the surface, and then I have the vector from my object that can also be like this, right? So given these two things, I can take the cross product of this vector and get that guy, and then I can take the cross product of this vector and get that guy. So I know my leaf will always be pointing away from the surface. Okay? So that's why we call it a double cross product. It's a double cross. Double cross. Okay, so let's try to set this up. All right. So I need, first of all, my guy here. I need point normals on this guy. So I'm going to use a facet node to give him point normals. So I'm going to plug that in there, and I say pre-compute normals. And if I turn on my normals, so there are my point normals. Okay. The next thing I want to do is I need to put these normals on my little lines here, because right now they don't have any normals. Okay. So let's see. How would I do this? So I need, first thing I need is a vector going from pointing at each one. So I'm going to use a polyframe for this. Polyframe. So I get an in and a tangent. So let's plug this in. And for now, I'm just going to turn this off. And let's see. So that's my in. I'm going to replace that eventually. And let's look at tangent u. So let's turn off my normals. And I want to look at tangent u. So I'm going to click my tangent u here. And let's shrink that down a little bit. Tangent u. Make scale, bring that down. Okay, so all these tangents are pointing roughly towards, let's do first edge. Yeah, so this guy is pointing at that guy is pointing at that guy is pointing at that guy. So I don't really need my in, I just want that tangent u. And I'm going to call this just tangent. I'll call this, what should I call it? Doesn't really matter what I call it. I'll just call it tangent. Because I'm going to build that orient out of that anyway. Okay, so I have my tangent, right? That's pointing towards my towards the next point. So let's turn this off. And so what I'm going to do is I'm going to grab my normals from my head here. So that's going to be an attribute transfer. So let's scoot this over. And I'm going to do an attribute transfer. Actually, this should be to the left. Should be to the left. And I'm going to do an attribute transfer. Transfer. So I'm going to transfer here to here. And I'm going to transfer. I don't need any primitives. I just want my normal data. So if I turn on my normal data now, right, these guys are all pointed away from the headpiece. Sweet. So now I have two vectors. I have the vector that's pointing along the normal, along the vine, and I have a vector that's pointing out from the surface. Super cool. Okay, now I can start to do my cross product. So once again, so if I draw this out, so my tangent u is going like this. My normal is going like this. Okay, so now I just have to decide what I want to be what, right? So what do I want this to be and what do I want this to be? So if my tangent u is, and actually I think what I want to do is I want to reverse my tangent u, because I want it, I feel like it's pointing the wrong direction. Like I want it pointing this way. So that's pretty simple. I'll just take and do an attribute expression, AE. Plug this into here. I'm going to edit my custom. And this is going to be points. I'm going to edit my tangent u. And I'll just say negative self. So they should just be pointing the opposite direction. Yeah. And actually, I'll even do normalize. Just to be safe. So I know my normal. So when I say normal, are you referring to UV as a grid, as a grid? No. I'm not using. I'm not. That is a good question. I'm not talking about UV space. I'm talking about U along a curve. So also in computer graphics, you can have a curve, right? And you can have a U value. So let's do. Where's my? You can have a U value. So that U value generally will go between 0 at the start and 1 at the end. So that's my U value. So 0.5 would be halfway down that curve. Okay, so I'm gonna plug that into here. Okay, so now I have my two vectors and I can start to build this coordinate frame. So to do that, I'm going to do that in, so I would usually do this in a point Rango, but I'm trying to learn new stuff. So I'm going to do this in a attribute VOP. So I'm going to do attribute VOP. And so I'm going to pop into this attribute VOP. So I remember I have my tangent u and my n. Okay. So my attribute VOP. So remember what I said. I want to keep. I think I want to keep that tangent u, right? So that I think I want that to be my y. I want my normal. What would be my normal to be my z, and then what's going to come out the side to be my x. So I'm going to bring in. I'm going to bind in. So this will be able to let me bring in this tangent u. Tangent u. And that is a float, or that's a vector 3 type. Okay. So, all right. So now I want to get my cross product. So I'm going to take my cross product here. So I already have my in here. And actually, because I don't want to use this thing, I'll just do in as well. All right, so I'm going to take the cross product. So I'm going to say tab cross product. So I'm going to take my cross. So let me draw this out as I do it, and I'm going to try to match my colors. Find a good spot. Maybe this spot right here, right? So there's my tangent u. And this is my normal. So the cross product of these two sticks should give me this, right? The cross product of these two, and these will be 90 degrees from one another. Okay, so I'm going to take the cross product of tangent u and in. And so just so we can see this, I'm going to just bind export. What attributes did you just bind into the VOP? I bound in tangent U and in. Okay, so I bound in this guy and this guy here. All right, so I'm going to take that cross product. I'm going to bind export just so I can see it. I'll just call this temp for now. And this will be a vector. And I'll visualize this. Is that a visualize as, let's see, type, marker, and vector. And vector, pull this down. And we'll make this red so I can actually see it. There we go. Okay, so there's our cross product. Right, so there's my cross product of, if I line this back up, of these two guys. Right, so that's going to be my temp. So now, so I have that. So let's, this was just for visualization, so I can get rid of these. Okay, so that's my temp. Actually, so I said I want my tangent U to be Y. This will be X. So my tangent U, so I'm just going to mark this Y axis. This is going to be my X axis. And then I'm going to take the cross product of these two again. So this is that double cross product again. So I'm going to say cross product. So this guy and this guy. So cross cross, this should be my Z axis. Okay, so if I visualize this, oh, what are you doing, Houdini? Oh no, fatal error, fatal error. Okay, close. Yes. All right, I'll do this on a simpler system. I overstepped my bounds. I got really excited. I forgot to save. I always do that. So I'll set this back up real quick. I'll just do it with just a single line and some noise on it. Let's see. D. Dark. Geometry. So I'll pop in here and make a line. And I'll do a, let's do 50 points. Okay, and I'll do a copy and transform. Oh, well, thanks. I'm glad you enjoy it. Let's do this, and let's go down the Z. Okay. So we're going to do just a row of vines now. So attribute noise. Plug that in. T. 0 centered. Okay. So we have all these kind of like vines here. Not as sexy as going over a kind of statue man, but still works. And let's do kind of do the same thing. Is I'll just put a sphere. This is the great thing about Houdini. Like I can set this up with like this really simple geometry and I can just swap out the complicated stuff later. So let's put a transform under this. I'm just going to flatten this out just a little bit. There we go. So I'm going to flatten this out. And we'll scoot it forward. And scoot it over. All right, so we got roughly the same idea. I'll put a facet on this to give me some normals. Okay, and then I will do here. I'm going to do that polyframe again. Should give me my tangent U. Yeah, that'll give me my tangent U here. Cool. And they're facing the wrong way, so I want to invert them. So attribute expression. And because I don't want to keep typing tangent U, that's fine. I can do tangent U. That's fine. So I'm going to do custom tangent U negative self. So that just should flip them over. Okay, so I'm going to do attribute transfer. If you can't tell, I've done this many, many times before, this little song and dance. Let me save this one more time. Let's just put this on the desktop. Cross vines. Here and here. Give me 1 second. Somebody's calling me. Hello? Hey, I'm still doing my stream. Alright. Okay, so there are my normals going that way. Okay. Sorry about that. So there are my normals going this way. And my tangent U going that way. Alright, so save. Alright, I'm gonna do a attribute vault. So we're going to do the same thing. So I'm going to say, let's see, bind import. It's going to be tangent U. It's going to be a vector. And let's say normal. Okay, so my tangent U, like I said, I wanted it to be my y-axis. Okay, I want to take the cross product of that. I'm just speeding back to where we were before. So this and this. So this will be my x-axis. I don't think Houdini liked me doing all that visualization stuff. And then I'm going to do another cross product. This is going to be my z-axis. Okay, great. So now we're back to where we were before. So now I have my 3, 1, 2, 3. They're all orthogonal to another. Now I need to make that matrix. Okay, so remember the matrix is my x, my y, and my z. So to make that, I'm going to do a let's see, matrix. Let's see, it's going to be vector to matrix 3. Vector. Let's see, where is it? I always forget where it is. Vector to cast, vector to float. Ah, here we go. Vector to matrix 3. Perfect. So X, Y, Z. So my X-axis is going to go into here. My Y-axis is going to go into here. And my Z-axis is going to go into there. So this is now my rotation matrix. Okay, so if you were here at the beginning of the stream, I can convert, right? So this is a representation of the orientation of this point, right? Or what will be copied onto this point. So I can convert this rotation idea, this idea of this rotation, this 3x3 matrix, into a quaternion. So I'll do that. So I'm going to say matrix 2 vector 4. Bang. Nope. It should be matrix 2 quaternion. Quaternion to matrix 3. Here we go. Matrix 3 to quaternion. Bang. Bang. And I know I'm on the right spot because my colors match. So matrix to matrix. Okay. So now I can just bind export this out to that orient attribute. So bind export. And this is going to be orient. And this is going to be a vector 4. Let's see, where is it? 3 floats, vector, direction vector, vector 4. Here we go. And I know that I'm right because those colors match. So bang, bang. All right. So moment of truth. If I've done this correctly, I'll show this. Should have a orient. And let's turn off my tangent U, and I want to turn off my normal. And I want to make this orient a little bit smaller so it's easier to see. So now, check it out. My Z is pointing away from the my sphere here. My Y's are pointing down, and my X's are pointing out to the side. Very, very stable. So I might not need this guy. Yeah, I want my Y's to point up, so I don't need to reverse that tangent U. So why have I gone through all this trouble? I've gone through all this trouble because what I can do now is if I take I'm just gonna do a cone. Actually, I'll just make another leaf. Yeah, let's make another leaf. So I'm just gonna do a plane or a grid. Actually, yeah, I'll just make a grid. Bang, bang. So I'll make this 0.1 by 0.1. So now, like this is gonna be my leaf eventually. So I'll do the same thing. I'll just put an attribute noise on it. Just give it a little bit of life. P. Zero centered. And able to bring that way down. And we're going to take our element size. Let's clear this. Element size, bring that down as well. we'll say that's our leaf. And so now I need to think about, like, if I go back to here, and that's so I need to think about which way I want this leaf to face, right? So my Z's are always pointed, generally are pointed out that way, right? So I want my leaf to orient to my Z as well. So here I'm going to put this. And there are more precise ways to do this, but I'm just trying to prove a point here. Okay, so now I have my leaf. Let's put some color on this. Just like a deep green. Okay, there's my leaf. So now if I do a copy to points, bang, bang. Now all my leaves are going to be pushed away from my sphere here. Actually, this guy here. So if I take this guy and I move it around, you'll see my leaves respond in kind. So they'll always try to face away from this object. So that is really, really powerful. Incredibly, incredibly powerful. Okay, so the other thing is I don't want every leaf to be on every point. I just want these to be scattered. So what I'll do is I'll do, so these are my points that I'm going to scatter onto. These are, so I'm going to say, I'm going to make a group, group expression. I have like this little 30% chance. I love using this one. So I'm going to call this seed. So if I view this, should be a point. So I'm getting about 30% of my points in here. And now I can place this. So I'm here. I'm going to say source group, target group should be seeds. Bang. Sweet. So they're all my leaves, and they're all pointing away. So now, if I want to go ahead and add in my vines as well, so I can take, let's see, this here. These are my vines. So I'm going to color these green for my leaf. I'm going to color these blue for stone, and I'll color these a dark green it's blue for stone, and I'm going to color these a brown for my vines. So my vine here, right, so I'm going to do a resample out here. And so what my resample is going to do is I don't want it to actually resample. I just want to make this curve U. So what this curve U allows me to do, it starts at 0 and it goes to 1 for each primitive. Okay, so I can take now and I can do a color. Color. Color, and I can say ramp from attribute, and I can do curve U. And so now this goes from black to white. So I don't want it to go from black to white. I want to go to from a super dark brown to a lighter brown. So there's my dark brown, my light brown, and for this now, I'm just going to use a sweep. And I want to say round tube. And I can bring my radius down, and I can also apply a curve to this. So I can bring my end point down like that. So there are my vines. And here are my leaves. And if I plug both of these together, so there's my vine and my leaves coming off of it. Fantastic. That's really great. So now I have my leaves and my vines all together. Everything's working together. Here. So my leaves are a little boring, right? They're all kind of pointing the same way. So I could add some randomization in here. Let's see if I can do that. I usually do this in code, so I'm trying to do less stuff in code and more stuff in nodes. Usually just point wrangle everything, but gotta learn new stuff sometime. So let's see. This is where my orient lives. So let's see, what could I do for? I can probably multiply another orient by this guy. So I know my Y's are facing up. So let's try to do that. So what I want is I'm going to get a random value from my point number. So let's see, what is point number? Yeah, PT number. So I'm going to do a random here. Random Sobol. Okay, so this should give me a random value between 0 and 1 based on my point number. So what I'm going to do is I'm going to make another quaternion. So basically what I want to do is I'm going to multiply those two things together. So I'm going to say quaternion. So I have my axis and my angle. So my rand is going to go in my angle, and my axis is just going to be y. Right, and then now I can take and I'll multiply these two guys together. Quaternion multiply. So A into B, and a product, we're going to there. So now I'm getting a random value for each one of my rotations. Well, that's number of points. I want point number. There we go. Let's see, this is angle. Let's just delete this, and we can see that this is turning from 0 to 1. So if I go -1, should go the opposite direction. So this random goes between 0 and 1. I want this to go between -1 and 1, so that's going to be a fit. So I'll take this random, put it in here. So source goes between 0 and 1, and this is going to go -1 to 1, and we'll plug that back into our angle. And now we have variation for our leaves. Super, super cool. Right, so a little bit of math allowed me to do all of this. And this is just with like simple geometry. I wish, sorry about the crash. because this would have looked really, really cool with that that demo head that I was working on. But wasn't in the cards today. So super simple stuff, but you can keep layering complexity and layering complexity and layering complexity. The other thing I might want to do is, these are kind of like pointing straight out, so I maybe might want to put them down a little bit. So where's my leaf? Here's my leaf. Let's put a transform on this. I'll rotate this down just a little bit. Those point down. Like that. And then the other thing I can do as well is I can do a p-scale. So I can say attribute noise. And that's giving them a color. So let's do float, and we'll do p-scale. So I'm getting randomized p-scales. So some of them are really big, and some of them are really small. Very, very cool. So if you combine this with kind of like the attribute from pieces workflow that we were using earlier, you can get some really fantastically naturalistic looking stuff. So let's bring this radius down. I always make my vines way too thick. Let's pull this down. Yeah, it's really, really cool stuff here. Really cool stuff. And maybe if I want more leaves, because there's usually a lot of leaves on vines, that's going to be in my group expression. Let's put that to like 0.6. So 60% chance of leaves. Pretty cool. All right, let's see. Let's see if I can get those leaves back on here. So I'm gonna come back, take this last 5 minutes, and see what I can get up to. Control C. I'm gonna save this for file, save scene as. I'm gonna put it. Lines. And actually, what I'll do is I'll just copy and paste that from another Houdini session. Let's do that. MoneyVal9 says another good topic would be I/O workflows between Maya and Houdini. Yeah, I can do that. Like, so I've seen workflows where you can build your foliage in Houdini, because you can make like a bunch of different variations, and then you can feed that into Mash, which Mash is kind of like a procedural placement in node in Maya. So that's also possible. So let's do open. I'm just gonna try to go grab the stuff that I was doing. Ground scatter. Let's go get. Where is? Oh no, that's not what I was looking for. Wow. Last modified. Foliage stream. That's what I want. So I'm going to pop this guy back open, and I'll just copy my leaf setup here. So I'm just going to take all of this stuff, and I think, yeah, Control C. I'll bring that over here and Control V. So there's all my leaves. just to show, I'm just going to do a single pass on this. So I just get one leaf, make it a little bit bigger. And so instead of my temporary guy here, take and plug this guy into here. Awesome. So with this guy, I want him to be facing down the z-axis. And I want him to be correct stem, like that. Maybe rotate it down a little bit. So there we go. Like this looks, oh man, this looks way better. Like, so that's one of the really, really cool things about Houdini is like I can get my system working and then I can replace my low res assets with higher res assets. Don't want that floating too far off the vine. And actually what I think I'll do, the last little thing, I'll put a bend on this. So let's go to here. And I'm just going to grab and put a bend on this. So tab, bend, plug that in, and pull my capture down, pull that down like that. Yeah. Put that in there. Yeah, that's looking really natural. Very, very natural now. So I want this to be, let's say, 0.8. Cool. So there we go. There you have it. Vines in Houdini. And this would work with the vines that I made crawling over that guy's head. It would make it, you could do this with like hand-drawn stuff. You could do this with, you know, a hair system if you really wanted to. So that's pretty cool. Pretty cool. And it's all still 100%, or not, almost 100% procedural. So if I don't like the orientation of this, the layout of these vines, I can always come into, let's see, my attribute noise. I can change that up. So I can make this noise stronger or weaker. I can give it some offset. Can change, what else can I change? Fractal warping, there's all sorts of stuff you can do this. So really, really fun stuff. I love doing foliage in Houdini. Like this is very natural looking in a very short amount of time. This maybe was maybe like 20 minutes. All right, so had another crash today, came back from it, feeling pretty good about it, feeling really good about this setup, and feeling really good about, you know, showing you guys how math is useful. Couldn't have done this if I didn't know, you know, about, so what did we do in our attribute vault? We used our cross product, we used 2 cross products, and we used a little bit of knowledge about quaternions to really, really enhance what we're doing. So if you ever want to make vines, if you want to make, you know, leaves, you can do it like this. And we can extend this. You can extend this with the points from pieces node, so you can get individual all the different leaves, a bunch of different types of leaves across your vine. They're not. These aren't supposed to wrap around this geometry. I'm just grabbing the normal from this geometry. So I would use that shortest path to make things wrap around it. There are also other ways to make things wrap around other things. So yeah, that's the stream for today. Thank you so much for coming and hanging out with me on a Wednesday night. I will probably extend. I'll probably extend this. I'll keep doing this. I'll go back to next week. I'll go back to the big statue head. I might do like a little scene with like twigs and stuff on the ground and like maybe some tall grass growing up around it. So yeah. So stay safe out there. Eat your vegetables. Drink water. Get enough rest. Be good to yourself. Be good to others. And have a good night. I will see you on the flip side. Take it easy, guys. and my deck is not working.